Okay, I'm gonna do, let's see, microphone, oops. Make sure I got this thing on, plugged in, looks good. Okay, so I'm gonna do I'm gonna skip 43, let you do 43 on your own. Look at number 45. So we have the function of two variables, f of x, y, equals x cubed y to the fifth plus 2x to the fourth y. We're asked to find all the second partial derivatives. So that means we want to find these four things. Partial of f with respect to x and then x again. Partial with respect to x then y. The partial with respect to y then x. And then the partial with respect to y and then y again. So we want to know what those are. So let me start off by first finding out what's the partial of f with respect to x. So I'm going to treat all my y's like constants. That's a constant, cover it up. Derivative of x cubed is 3x squared. And then bring the y to the fifth in. Okay, plus, now again, covering up the y because it's a constant, derivative of 2x to the fourth is 8x cubed. But then we have y still, because it was our constant. So that's our partial with respect to x. Let's go ahead and find the partial with respect to y while we're here. Partial with respect to y would be, cover up the x because it's a constant, derivative of y to the fifth is 5y to the fourth. So 5y to the fourth, but I still have an x cubed there. And then over here, 2x to the fourth, that's all a constant. Derivative of y is 1, so I'm just going to get that constant. Plus 2x to the fourth. Okay, now, I'm going to try and find these four things. So what would partial of f with respect to x, then x again be? Well, that's the first partial. So I want to take, with respect to x, I want to take the derivative of that again with respect to x. So cover up the y to the fifth. This is going to be 6x. And then I still had the y to the fifth. Plus, again, cover up the y here. Derivative of 8x cubed is 24x squared. But I still had the y because it was a constant. So that's my second partial that I'm trying to find. Let me do partial of f with respect to x, then y. So start with this and then take the derivative of this with respect to y. So this time, x is a constant. So cover this up. Derivative of y to the fifth is 5y to the fourth. The 5 comes out, hits this. So we'll have 15. The x squared stays there. This power came down, y to the fourth. And then over here, cover up the 8x cubed. Derivative of y is going to be 1. So derivative of y is 1, so we just get plus 8x cubed. See what that is. Okay, student. Okay, so now we're going to do, let's do partial f with respect to y then x. So that's this one right here. We're going to take now the derivative of that with respect to x, which means that y is a constant. So cover this up. Derivative of x cubed is 3x squared. So 3 comes out. It becomes 15x squared. But we still have y to the fourth. And then over here, we're taking the derivative with respect to x now. So this is all a variable. So it'll become plus 8x cubed. Hey, these are the same. Interesting. All right, now next one, fyy, would mean we take the partial with respect to y, which is this one, and then with respect to y again. So forget this is here. Derivative of y to the fourth is 4y cubed. The 4 comes out, hits the 5. So we'll get 20 x cubed, and then the y is now y cubed because power came down. Plus, now this is all a constant because we're treating y like the variable, x like the constant. So that's just plus 0. So that's it. Those are your second partials on that. All right, let's look at number 51. we want to verify Clairaut's theorem. So we're going to take a look at a function. U is equal to x to the fourth y cubed minus y to the fourth. Oh, by the way, I'm not doing number 47 and 49. I'm going to let you do those. Same principle as number 45, but they're a little more complicated. For this one, I want to verify Clairaut's theorem. So I don't know if I'm going to actually go through this. I'm just going to tell you what you have to show. You have to show that the partial of f with respect to x then y is equal to the partial of f with respect to y then x. So that if you do these different orders, right, partial with respect to x first then y, that should be equal if you do equal to doing the partial with respect to y then x. And there were some conditions in the theorem. You know, you had to have that this was a nice continuous function on a closed or on a disk or something like that. And this is a continuous function, two variables, because it's polynomial. So we know that polynomial functions in two variables are continuous everywhere. So this should work. So just go through and take these second partials and show that they're equal to each other. All right, number 53. We have f of xy equals x to the fourth y squared minus x cubed y. And you're asked to find f x x x and then f x y x. And I'm just going to do one of these. So I'll do this one. So what we're going to do is first we're going to find the partial with respect to x. Okay, so we start here. Partial with respect to x here is 4x cubed y squared minus 3x squared y. And then if we do the partial of that with respect to y here, 2 comes out, so we'll get 8x cubed y minus, with respect to y here, this right here is our variable, so that's a constant. Derivative of y is 1, so we just get negative 3x squared. And now if I do the partial with respect to x again, so we did the partial with respect to x, then partial with respect to x, then y is this one. And now we're going to come in and do that answer with respect to x. So 3 comes out, we get 24x squared y, because y is a constant. And then derivative of this with respect to x, which is negative 6x. So this is it right here. All right, number 58. They're asking you to find, well, that's just trying to get you to understand some notation. So I think that's, again, one of those ones I think I'll let you do on your own. See if you can make sense out of the notation there. And is that it for this assignment? I believe it is. All right, so I'm going to stop the video.